Okay, so in this video, we're just going to discuss how we can run DC motors using our microbit and our all-in-one Keytronic breakout board. Now, on this all-in-one Keytronic breakout board, to run your DC motors, all you need to do is power the unit itself, so the breakout board. The breakout board can take up to 10.8 volts. So what I tend to do is I use these two terminals to take a 9-volt battery. Now, we know that all we need is 3 volts to run our microbit itself. And usually we provide that power through this connector above here, or once we have it plugged in with a micro USB cable. But what's great about this board itself, once you have that 9 volts plugged in here onto this terminal, it will actually supply 3 volts directly to the board as well. So we'll step down that voltage and provide that 3 volts here. Now, once we have it powered, all we need to look at then is our 4 motor blocks. So as you can see here, we have motor 1, motor 2, motor 3, and motor 4. So there's 4 separate blocks here. And there is 2 connections at each one of the blocks for a plus and minus. So technically we can run 4 DC motors using this board itself. The only thing you're really limited by is the 10.8 volts, but a 9-volt battery should be more than sufficient to drive 4 motors at sufficient power. Now, just have a look at the variety of motors that we have to choose from. Now, the motors themselves come in all different shapes and sizes. As you can see, this is quite a small one. Actually, this one came out of a remote control of a PlayStation. This provided the rumble, which actually caused the vibration, which used to have a bit of a weight here, and that used to spin around fast, and that used to do the shaking function on the remote itself. While this very large motor came out of a grinder, a battery grinder, that broke. Now, a motor like this is too large to run by a board like this because you don't have enough voltage coming out of it to run it. But the principles used for these to run are pretty much the same. A motor itself, DC motor, you'll know it straight off the bat, especially when looking at it compared to a servo motor and a stepper motor, because it has 2 wires, while a servo motor would have 3 because it has the additional signal wire, and then a stepper motor because it has multiple wires, as you can see over here. This is an example of a stepper motor with loads of wires on it. But all we have is a plus and minus for our DC, as you can see here and here, as well as some of the other ones, such as this one here, and I have 2 more inside here which are the same. Now, the standard motor itself comes like this, where you just have the motor itself. But what happens with motors like this is that it has low torque. So the way the power behind this rotating, so the torque that it has is low. So I could stop it with my hand, especially with this smaller one. Now, this larger one isn't too bad, but it's quite a large form factor. But the main thing for these motors is that they run at high RPM. So revolutions per minute, so they rotate extremely fast but with low torque, while other DC motors come in these form factors where they have gearboxes on them. So you have the motor back here and you have a bit of a gear train, which is the gearbox itself, which reduces the speed of the motor and increases the torque out of the output shaft, but also reduces the RPM, so that rotational speed. You can also see that here with another DC motor. You can tell it's DC because it has its 2 connections, plus and minus. Depending on where you put the plus and minus, the direction changes. It will go anti-clockwise or clockwise. And you can see the output shaft is over here this time. This will run quite fast, and the faster this runs, you can see the shaft, which is driven by this gear over here. So if I turn this fast, you can see that gear is barely moving. So the output shaft is barely moving when this is rotating fast. So it's basically reducing rotational speed at this shaft, but increasing torque. And that's the same with this motor over here also. It has the standard motor on the back. You have your plus and your minus connection, and you have your gearbox, which reduces the speed of the motor and increases torque. Now, depending, if you want to know the gear ratio, We have our gear ratios here, so we can see this is a 1.5 to 3 volts, so that's the power it takes DC, and it's 100 to 1. So basically for every 100 times this motor rotates, so the output shaft of the motor, this shaft rotates once. Now for this demonstration, we're actually going to use this motor and connect it up to the breakout board itself, and I'm just going to go through after that how the code itself goes together. Now to wire it up, you can have a look at the diagram that I've supplied up on the website itself, but it is very, very simple. All we really have is our 9-volt battery, which is powering our breakout board, which is going to power our microbit with 3 volts. And then I've just connected 2 wires to motor block 1 here. It doesn't matter which one goes in first and second, so it could be black or red first or second. And it doesn't matter if black or red which side of the motor it goes onto. The only thing it's going to change if you change these around or change them around is the rotation of the shaft out the front. So for instance, if I turn it on now, once I have my code loaded and this rotates clockwise, that means if I change these around, it will start rotating anti-clockwise and vice versa. So what we'll do now is we'll just go over and we'll have a look at the coding and just show you the simple extension that you add, as well as the few blocks you put together to run this motor. Okay, so to use your DC motor in conjunction with your all-in-one breakout board, all you need to do is add your extension first of all, which is for your Keytronic all-in-one breakout board. So go to extensions, go all in, an all-in-one breakout board, robotics board here by Keytronic should pop up, and click on that, and it gives us this extra tab over here, robotics. When you click on it, you can see we have several more tabs below. Now before we use any of those, I'm just going to get rid of my on start block, because I don't need that, but I do need my forever block, so this is always happening whatever's inside here. So I'm going to go for my motors, so it's a standard motor we're using, so just motors, DC motor, and then motor 1 on direction forward speed 0. We're going to be using this one, so we pull that out and drop it in. Now this 1, 2, 3 and 4 we can choose from. That relates back to the basically what block, motor block you're using on the board itself. If you remember back, we connected ours to motor block 1. And now if you're going to 2, 3 or 4, you can change it to whichever one you're using. So I'm just going to go at 1. And we're going to go forward at speed 100. So 100 means they are 100% of the power that the board can send. So from whatever battery you have, so for instance I'm using a 9-volt battery, so 100% of the 9-volt battery that can go to this motor will go to it. While if we said 50, it would be 50. Now if we had the full 10.8, it would obviously go faster at 100 than it would with the 9-volt, but because we have 9, 100% is just all we can give it is the 9 volts. Now rather than just letting the motor travel forward always 100%, we're going to give it a pause afterwards for 2 seconds. So basically we're going to let that run for 2 seconds like that forwards, and then we're going to put another one of these motor blocks. Now you can retrieve it inside here by clicking on box, going for motors and clicking and dragging it out, or you can just right click here and duplicate, which I like to do because it saves me a bit of time. We'll go for our motor block 1 again, but this time on direction we'll change it to reverse and we'll leave it at 100% speed again. Now speed should be slower because we are using a motor which has a gearbox that reduces the motor speed and increases torque, so it won't be traveling at too fast of a speed anyway. Now if we leave it like this, what will end up happening is start off, motor 1 will go forward 100% for 2 seconds. And then all of a shot, it will go to motor 1 reverse speed at 100% seconds. But before it gets a chance to do that properly, it will jump back here to the start of this again. So what we actually need to do is duplicate the pause, so it has a bit of time for motor 1 on direction reverse at 100. So we'll give it 2 seconds there. So now each of these should have 2 seconds to run in their direction, and we'll see how we get on with that. Now that we have it all wired up, all we need to do is ensure that our microbit has the code transferred across. slot it into our all-in-one breakout board, ensure that our battery is connected, and that's going into our terminal block, and we turn on our switch here on our all-in-one breakout board. As we can see, our motor is spinning in 2 directions for 2 seconds each. So 1, 2, 1, 2, 1, 2, 1, 2, just like we asked it to. Now, if you changed the timing, the weight, it would just extend the time it rotates in that direction. But as well as that, if you change the polarity, so if you change the plus and the minus here, or change it back here, it will just change which it does first, clockwise or anti-clockwise.